Okay. Hello, everyone. Can you just give me a text message just to make sure that it's working correctly? Yeah, okay. Good, good. Okay, so today's chapter is about JUnit, and JUnit is kind of like our only chapter where we're doing automated testing. Okay, it wouldn't be a testing course without there being an automated testing component to the course. One of the most popular ones, especially one of the most popular ones that are being taught in academia, is the JUnit framework, and that's because it's free. So is Java. Nonetheless, the concepts are actually very similar to many other platforms. Um, when you look at, if you want to look up the user manual for it, you're actually, see, let me actually get out of here for a second. I encourage you to, where is the web page? Oh, I closed it. Just go to junit.org. Let me see if I can pull it out. I had it yesterday. I probably just closed it. Okay. And let me share the screen. So now you're supposed to be seeing the website, right? I just found out recently there's such a thing as share screen, and without having to keep sharing every single page, and it just goes back and forth, yeah, right away. Okay, so now, yeah, very good. Okay, so this is JUnit. When I started teaching this chapter, it used to be JUnit 4, but now it's JUnit 5, and it's very helpful when it comes to creating a lot of tests and regression testing and automating those tests by creating suites, and they run all the suites and they give you a report. So it's very good. Obviously, it works with your Java programs. I think JUnit, if I remember correctly, was one of like the first to come up with the XUnit aspect of testing, where you are writing unit tests in an automated way. And then afterwards, C# came up with something similar. Website, all of them have these XUnit components, testing frameworks, and they work more or less in the same concept here. Okay, so let me just go back now to the slides over here. Okay, so what we're going to be doing in this chapter is we're going to be looking at JUnit as a Java testing framework, use it to write executable and repeatable tests, and how we're going to create some tests with JUnit, in particular unit tests. JUnit was originally written by Eric Gama and Kent Beck. I remember last lecture, I mistakenly said that refactoring was actually created by Kent Beck. I flipped the names. Actually, refactoring was created by somebody called Martin Fowler, who works at a very big company. It's called ThoughtWorks, and they do software development for globally. Okay, it's a big company that has offices in at least 50 countries. Okay, and he's like one of the head software developers. It's a big name, Martin Fowler, but also so is Ken Beck. All right. So let's just say we have two classes. Okay, one of them is called account service, which provides services for account. Okay, basically, this account service class, you give it an account, and it starts to do something, work with it. You can add the account, update the account, delete the account, and so on. The account itself is formed as an object of type account DTO. All right. DTO it means data transition object, and this is very helpful in process-oriented systems where the data is actually traveling as a piece that is irrelevant from or disconnected from the actual processes that are being performed. Anyway, account service class it has these services, add, update, and delete, and you have to give it a DTO object in order to do something with it. All right. So traditionally, what we would do is we would write a test, and at the bottom, let me actually pull out the pen because I'm going to need it at some point. Okay. So for example, here I am. I've created a DTO. All right. And then I run my test like, I do the add and update and delete, and every time I go and check the results of it. But there's a couple of issues here. The first of which is, what if test number one fails in respect that it actually throws an exception? Okay, well, test number 2 and 3 is not going to run because the program is just terminated. The other thing too is, what if the effect of what's happening in test 1 actually affects what's happening in test 2? There's a history being carried over, and maybe we don't want that history. Maybe we just want to have a fresh start every time we are running one of those tests. Obviously, in this particular test that you're seeing right now, we do want to hold the history because you want to add it, update it, and then delete it. You wouldn't want the history not, but in case we do want the history not to be carried over and each test is actually independent, then we don't want to actually have the effects that has happened from running a test carry over to the next test. All right. So this is the issue that we have, and hence comes the JUnit framework. Okay, it helps us prepare those test programs by creating a test class, and within that test class, just like we saw here, it's going to be called account test, but it's going to be special in that it's running over the JUnit framework, which helps alleviate the issues that we just talked about it before, where if one of those tests throws an exception, what if we don't want to carry the history over? We can have features in JUnit that helps us do that. All right. So let's take a look at the features of JUnit. Basically, JUnit comes with a number of fail and assertion methods. Now, assert means basically saying, I'm expecting the output to be such and such. And it takes two parameters, what you're expecting and what the actual thing you're testing is. Fail is the same thing, okay? Fail, it means that I'm expecting a failure. Okay, I'm actually expecting something to fail, right? And again, this comes in the form of where, we don't want the software to be doing something that it's not supposed to be doing, all right? So after all, really what is all testing? Testing is, I put in an input, I get an output, I check the output if it's what is the same as expecting or was it not the same as I expected, okay? With it, I can create a suite of tests. Okay, a suite of tests means a whole bunch of test cases that I collect together in a collection, right? And then I can execute them in one shot, which is very, very helpful when we're doing regression testing, okay? So let's just say, you had 10 tests you've created, okay? And then test number 10 is dealing with the most basic unit that you have. Now, that basic unit have changed, and you want to change accordingly test number 10. All right. Now, after we've edited test number 10, we still want to be checking the regression of our test cases. Okay, the regression testing of our code, making sure that the other units that are depending on the unit that we've just changed, they themselves are still working. Okay, because it might have a ripple effect. It's a very, very big deal. Okay, you change something and that something works, but then everything else that was depending on it maybe doesn't work. Okay, when previously it was working. Okay, it's a funny concept. All right. Nonetheless, having already created those test cases, we put them in the test suite. All I have to do is edit the first test case, and then basically I need to rerun all my tests again. So having them all in a test suite that they're automated and can be executed is good for regression testing as well. I can run JUnit in graphical and what we call textual runners. So in the textual runners, you have like a command prompt. You can just say, run this test suite for me. And a lot of the common IDEs now, the more the decent ones, any decent one would have an ability to have that JUnit library, and then you have a graphical user interface to actually run the test, so you don't actually have to write down any command line prompt. But just about with everything in development, there's always the command line version, and then there's the graphical version as well. Like I said, the most current version is a 5.9. I think it's now 5.7. I think last time I saw it. And one of the features of 5, and I think it exists also in 4, is that it supports annotations. Okay, so if this is my test case, so this is a test case for that class account service. Okay, I'm creating a class that represents a test case. You see how this works? Okay, so I have my account service class. I also have my account DTO class. Now I'm going to create a class. Okay, and look at it. It's actually a full-blown class. Okay, and I usually the common format is I use the same name followed by the word test case. Okay, and then next up I use this annotation of at test. Okay, now at test would be considered something like a comment. However, if you have the JUnit library installed, it would actually make sense of it. Kind of like JavaDoc. So JavaDoc has the same component where you write down something like, say, at author, all right? And when it publishes the documentation for the code, actually, it runs through the code, reads all these annotations like at author, at class, at this, at the, and these are documentation, so that you basically click run and it produces a whole bunch of documentation for us. And I'm going to show you an example of this documentation being produced automatically in a moment. Okay. Anyway, so we have a method called test add. And again, notice this, the word add is preceded by the word test. And obviously we don't have to name it as such, but it's the convention. Now this add, if you look back a few slides ago, this was one of the functions that we had over here. Okay, so if you want to test it, if you want to create a test case for that function, you just write the word test add. Okay, test update, test delete, and so on. All right, so I got a test add over here. All right, so I created a DTO object, I gave it an ID. All right, I set a number, and then I add it. Okay, and then after I add it, I try to retrieve it. Okay, so after I retrieve it, if it happens to be null, means I wasn't able to retrieve anything, this thing that I just retrieved. So I'm going to use a fail function. Now, fail functions, again, is one of these functions that comes with JUnit. And basically, this fail function says that a test has failed and its outputs the given string. So if it fails, if it is DTO, then basically our test has failed, and it just prints out this message over here. All right. So far, so simple. All right. Yeah, I'm just basically, I've actually tested the failure here. Okay, at this point, right? So far, I'm not really making much use of JUnit, but we're getting there. Okay, so I've kind of like did the test prior, and then basically I said I failed. Okay, but now I'm going to get JUnit to do the test by actually using the assert function. Okay, so assert, now all of this code is exactly the same as we had before. All right, now what I'm going to do is, instead of doing the test myself over here, I'm going to use the DTO over there, and I'm going to do assert null. Basically what I'm saying is I'm expecting this to be null. All right, in other words, for some reason, had this been a null, then go ahead and print this. And obviously that means the software has failed. The software itself has failed. Now, the word assert means I'm expecting something. Okay, assert null, that means I'm expecting a null value. Okay, and if this happens to be an actual null, then this is printed. Okay, so it's kind of like similar to what we had in the previous slide with the fail, except for now I'm saying, in case this was expected to be a null or happened to be a null, then produce this. Okay, but what if it wasn't? Okay, what if I wasn't expecting it? I can just write something like, say, assert not null. Okay. So in this particular case, I have to my assert function is called assert not null, and basically not really expecting any particular value, but rather I'm expecting that this DTO would not be null. And if it's anything other than null, then go ahead and print the account is not deleted. Okay. And again, this particular test case, I'm testing the delete function of the account service class. And with it, I can create any test case for any particular function. And I can also create, do any sorts of assertions. Okay. So if I just leave this for a second, go to the website over here. So all I have to do is just write down, you see the website? Okay. Assert methods. There we go. Yeah, click that one. All right, so if you see over here, I have a whole bunch of assert functions that comes with JUnit. Okay. I can assert something is equal to something, an object, or an actual string. I can assert that something is a false, null, not the same, right? Assert that something, there's a whole bunch of other things that comes with assert, and you don't actually have to study all of them, but the point that I'm trying to make is there's a ton of features that comes with the JUnit library, and you can use each one of them depending on the situation. So maybe you want to compare an array with what you're expecting in an array. You want to compare that the result of a Boolean is a false, or the result of a Boolean is a true, or is that you got two things and they're actually the same, regardless of what they are, or they got two things and that they're not the same. Okay. Yeah. So you have an expectation, comes with the word assert, and then finally, basically you get the result. And if the result is equal to something, usually, as you can see over here, there's a string message. You almost see that in almost all of the assert function. And that string message is what you print had the result of the assert was a true. Okay. So if what you're asserting actually happened to be the case, then it's going to print this for us, right? Going back again over here, this is what you see in front of you. This documentation, that was actually automatically produced. Nobody actually created that website by hand. And that website is actually created by using something called JavaDoc. And JavaDoc, what it does is we insert certain annotations in the code so that basically you run the JavaDoc function on your source code and it produces this over here. And the beauty about it is that, a lot of this stuff is hyperlinked. So you click on it and then it takes you to, the detailed explanation of it. So you see parameters, expected, actuals, the signature, right? All of this is produced automatically for us, right? And it even has other links to other things. So if you next, I got the string over here, and then it's going to take me somewhere completely different because that is just something that comes with the original Java. Okay. So the string class. Okay. By the way, like for example, this text you see over here, this text that actually is written in the code. So class string, if you open it up, you'll see that code written in there. Okay. Anyway, just going back over here, and I'm gonna go. I do double, and actually, if you notice that website, you see this over here. That what I'm pointing at, it says JavaDoc. Okay, so this documentation that we just saw a moment ago, that's actually created by JavaDoc. All right, go back again to the slides. Okay. And like I said, we have many. Okay, assert equals, assert true, assert not true, null, same, not the same, and so on. Okay, so obviously having to memorize all of them is not the purpose, but at least you should know the most basic ones. Okay, true, assert false, equals, not null, null, same, not the same, and so on. Okay, at least the ones that you see over here, you should be able to make sense of them, right? The funny thing is that even if you couldn't remember it, just basically you're trying to remember what you're trying to do in a question. And then if I ask you, say, write a test to make sure that the result of the Boolean is a true. So basically you say, well, I'm assert true. So basically what I'm asking you for, you just put the word and you put the word assert. Usually it will be right. Chances are it'll be right. Okay. Unless you write something like assert correct, then you're really, really bad in luck here. Okay. Anyway, there's other annotations. Okay. One of them we just saw, and it's called at test. And at test, which we saw over here, this, it's not this, but it's this one over here, that at test is what tells JUnit that this class is a test class. So it treats it rather special, okay? And it's gonna look at it and it's gonna try to match the word over here, the word delete, with the function in account service. It's gonna do the matching. And so when I do this over here, all right, and the DTO and so on, it's using account services functions for that purpose. All right. So at test says that this is a test case. For some reason, maybe at some points we want to ignore particular test cases. So I put the add ignore. Okay, which means that all the test cases that all the test methods that I have in this class will be ignored just for temporary reasons. Okay, for some reason I just want to disable that test for now. I can just put the add ignore, and if I want to go back and run those tests, I remove the add ignore annotation. Other annotations that are very, very important that come with the life cycle, they handle the life cycle of a test case. We have the add before class, add after class, and then we have add before and after. Okay, and they basically help us with the setup and the teardown. Now, setup comes in two forms. Okay, there is the setup that we want to do for the entire class so that we can run all the tests, and then we have the teardown, which is after we finished with all the test cases, right? We want to leave the system in a stable, safe state. Okay, so we use the at after class annotation. So as you can see over here, before we begin with all of our test cases, we set up, and the at after class is what we do towards the very end after we've done all our test cases. Now, here, when we're actually running one test case at a time, okay, we have the at before and at after, and this is kind of like the ones where we're setting up just the part for that a particular test case. So as you can see, we have a for loop over here that's just running through each test case, and for each test case, maybe I want to insert a different value. Chances are I'm going to insert a different value. So I do an add before and then an at after, in case what has just happened from that particular test case, I want to remove its effect before the next test case runs. Okay, so the add before and the at after applies to test case by test case, whereas the add before class and add after class is what happens before we begin all our testing and what happens after we're done with all of our testing. All right, if you forget, just remember the word class. Okay, add before class. So the word class means I'm talking about the class level, not talking about the test case level. And similarly with the add after class, I'm talking about the class level. So if you use the word class as a hint to remember which one is which, so you're not confused between the after and the after class. All right, just remember that the word class is we're dealing with the class in total. So the class in total has a whole bunch of test cases. All right, and so we're not talking about a particular test case or what we're doing for a particular test case. All right. All right, so add before class and annotated public static void, no argument, will be executed before the execution of any method in a class. And that's usually for initializing necessarily valid variables and objects, whereas the after class is also an annotated method, okay? and it has the purpose of the teardown after testing, which means we're cleaning any effects from running the test cases. Whereas the add before and the add after, okay, we call that before each test case. And this is, again, this is for any last second setup required for the execution of a particular test method. Okay, so a particular test case. Okay, and if I want to remove the effect of a particular test case, I use the add after annotation for last second cleanup before the next test case runs. Okay, guys? All right, now we're interested in creating test suites. Okay. And basically, the test suite is helpful when I want to add multiples of test classes. Okay. So a test class will have multiples of test cases. Okay. Pretty sure you understand this UML notation. Okay. And a test suite will have a multiples of these test classes. Okay. And the concept here is, in your code, you have a whole bunch of classes. Okay, class A, class B, class C. Okay, each one of those, I'm creating different test cases. Okay, test case, right? So on and so forth. Okay, so the test class brings together all these test cases, and then the test suite brings together all of the test classes. Okay, and with the test suite, I can obviously run all the classes and the whole software. In other words, I'm testing the entire software if I really want to. If I just want to test a subset of classes, okay, maybe the classes that belong in a particular subsystem, then my test suite obviously would just include those test classes. So how does it look like code-wise? Okay. All right, so I have a class called all tests. And the first thing that I want to do is I want to be able to create a test suite. Okay. And so in this test suite function, which is called get suite, it returns a test suite. And then I end up creating the test suite itself. Okay, so I have something called test suite. I'm just going to call it test all. And then all I'm doing now is, remember, I need to add those classes into that test suite. Okay, so I get the suite, and then I say add to the test suite. Here's one class. Okay, remember account service test case? If you look back a few slides before, this was it. This was a test case, okay, or a test class. And back again over here. And how is it that I retrieve the class? I use the dot class method that comes with Java. So dot class actually comes with Java. Every class, if you want to just grab the class itself, you use dot class. And then basically the test suite has this test case added to it. Okay. Similarly, with a different class called use service. All right. And again, I added to my suite. And then I finally return the suite. Okay. So a little later on in the code, when it's time to run the test suite, I have something called a runner. Okay. We're going to look at the textual version of the runner. Okay. So the class test suite, it comes with JUnit. All right. Obviously, along with the add test suite function, which is the one was over there. So that comes with test unit. All right. In order for all of this to work, you have to import the JUnit library. And again, I'm going to step out here for a moment. Okay. Just basically write down Google. I'm just write down import JUnit. It's kind of like to show you what this looks like. Import, yeah, there we go. So we import the JUnit over here, all right? And then, yeah, and then you start to do your magic with your JUnit library. So finally, you want to be able to run the test suite. We have something called the test runner. And again, test runner comes with JUnit. All right. So in the main function of your code, you would write JUnit dot textual interface dot test runner dot run, and then basically you write down get me the suite. What is the suite? This is the one over here, which grabs the test suite itself. And so the test suite is given to JUnit's runner, okay? And then it starts to run all the different test cases that you have, okay? So it's a pretty straightforward chapter. It's a very small chapter. It's a very small lecture as well, too. Just pause here for a second. Oh, no, that's not it.